So we had the rational zero theorem yesterday. Today we're going to talk about some irrational numbers. Remember, a rational number means it can be what? What's a rational number? Fraction. It can be written in the form of a fraction. It can be a whole number. 3 is a rational number because we can represent it as 3 over 1, right? All right, so irrational numbers means that we can't. So that it is most likely going to be like a square root or pi or something like that for you, okay? So we're going to look at irrational zeros before we talk about the rational zero theorem, or before we use it with the irrational zero theorem. So it says to find all the zeros, write answers in simplest form. So we're totally capable of doing this. This is a fourth degree polynomial, right? But it's set up like a quadratic, which means I can try to factor it, right? If it's factorable, I can factor it. So if I factor this one, this is going to be x squared here and x squared here, right? This is positive, therefore the signs are the same. This is negative, so they're both negative, okay? So what are my two numbers that go in there then? 6 and 3, right? 6 and 3, just like that. Now, can I factor that anymore? Nope. It's set up like what? Like if I had different numbers in there, this looks like it could be a difference of squares, right? The problem is those numbers aren't perfect squares, right? So what we have been saying once we get here is we can't factor it anymore. The truth is we can factor it some more. It's just not factored completely yet. And so we should kind of be careful in how we state those things. We're done factoring right now with the skills that we have right now, but we can still find the zeros. Now, once I'm done factoring, which I am for right now, then I don't just leave it like this. This is like an incomplete equation, or most of you wouldn't even put the equal signs there if you didn't do it. And so that's just an expression. Once I'm done, f of x equals this. You have to make sure you're labeling what you have. That's something that's a lot of you really need to work on, okay? And then at this point, what I need are my zeros. So these are two terms here. I can split them up, and I can do x squared minus 6 equals 0, right? That means that x squared equals 6. So what does x equal? So close.
Plus or minus square root.
Plus or minus. When you introduce a square root, you cannot forget your plus or minus, right? There are two answers here. So plus or minus square root of 6. Okay, plus or minus, plus or minus. All right, so then over here, I get x squared minus 3 equals 0. So x squared equals 3. So x equals what? Plus or minus square root of 3. Okay? When you introduce a square root into something, yes. And I always say it's when you introduce it, because if you start off and in the question there is a square root already, you don't get to just go add a plus or minus. But when you are taking the square root of something, then yes, because you have two different answers, because we don't know which one it is. It's a good question. Anything else? All right, so my zeros then, because it says find all the zeros and write them all in simplest form. So my zeros are plus or minus the square root of 6 and plus or minus the square root of 3. I have 4 of them, but they're packaged together. Everybody okay with that? We good? All right, so number 2. Once again, it looks like it is set up like a quadratic, even though it's a 4th degree. My a is not 1, so I'm going to walk you through the grouping process. If you do something else, whatever, that's on you, but grouping is something that I would suggest. This is going to be 32 here. So I need two numbers that are going to multiply to give me 32 and combine 33. 32 and 1. So I've got 4x to the 4th, then minus 32x squared minus x squared plus 8. Remember that first step of the grouping process is just to split that middle term. And then I factor out of the first two terms, I can factor out a 4x squared. That leaves me with x squared minus 8. Then out of these two terms, I can factor out a negative 1. And that leaves me with x squared minus 8. So then I, in the end up with 4x squared minus 1 times x squared minus 8. Am I done factoring? No. I can factor this some more, right? What is this thing called? Difference of squares. Good. So this is going to give me 2x plus 1 and 2x minus 1. X squared minus 8 I can't factor anymore right now. So this is my fully factored function there. And then I need to solve these here. So for this one, what does x equal right here? Yes, so I have them split up, so right here I'm going to put negative 1/2, but yes. And then this is x equals 1/2. If you need to write it out equal, I wrote it like all out over here, but I know that you don't necessarily need to write it in these anymore. So since x squared minus 8 is going to equal 0, I can say that x squared equals 8, right? So x is going to equal plus or minus the square root of 8. Can I simplify the square root of 8? Yes, you can. You can simplify the square root of 8. It's not a perfect square, but you can simplify it, right? That's what we did in math time? Okay, 2 square root of 2. All right, so x is going to equal plus or minus 2 square root of 2. That's that x value. So I have these right here. Then I need to put all together. I'm kind of running out of room. I'll put it sideways. My x values are plus or minus 1/2 and plus or minus 2 square root of 2.
With this one, you always have to put the number from least to greatest, right?
Well, you're supposed to. But with the plus or minus, that kind of makes it a little not so easy to determine sometimes. Okay, so it's fine. All right, we okay with that? So much writing. You hadn't seen nothing yet, dude. All right, let's look at number 3. He said there's so much writing. Poor little Michael. Okay. We'll do some hand exercises or something. I don't know. I'll put some nice lotions on your tables, just in case you're, whatever. All right. Number 3. We're going to factor this. We will factor by. Can we factor by grouping? Yes. Yes, we can. So out of these first two, what can I factor out? X squared. That's going to leave me with 2x plus 5. Then what am I going to factor out of here? Okay, so I can divide by negative 6. That would leave me with 4 and 10, but I can do 12. Because if I do 6, it doesn't match this, right? So this kind of gives it away. Like if I can do it by grouping, I'm going to have to be left with a 2, so I can factor out my 12. And this leaves me with 2x plus 5. Okay. So that means that I get x squared minus 12 times 2x plus 5. And as far as we know, we can't factor anymore right now. Would you agree with that? All right, so f of x equals. So then I get that x squared minus 12 equals 0, or x squared equals 12. I could have skipped that. So x is equal to plus or minus the square root of 12. Can you simplify the square root of 12?
Yeah, 2 and 3.
Well, something has to stay inside because it's not a perfect square. But if I have this, I can split it up into 4 and 3, which means that okay, but when you say 2 and 3 or 3 and 2, like that, those are just numbers. 2 square root of 3. So x is equal to plus or minus 2 square root of 3. You've got to make sure that you're pulling the correct thing out of the square root. Okay? All right, so there's that side. And then 2x plus 5 equals 0. So x equals what? Negative 5 halves. So there's the other part. So that means that x is equal to plus or minus 2 square root of 3. 2 square root of 3 and negative 5 halves. Okay. Everybody okay with that? Any questions? All right. We're going to do 4 as well. All right, so here, can I factor by grouping? Think it's going to work? I think it might work. So in the first two, I can factor out a what? 3x squared. So that leaves me with x minus 5, right? What do I factor out of this one? Negative 4. And that leaves me with x minus 5. So that's good, because if they're not the same, we've got a problem. Then this is going to give me 3x squared minus 4 times x minus 5. And so that is f of x there. I factored. Poof. Like magic. Okay. Can I factor any more right now? There, yeah, there's nothing else I can factor with our factoring skills that we have right now. So this is what we have right here. So I know that 3x squared minus 4 equals 0, right? So 3x squared equals 4, which means that x squared equals 4/3. So x equals plus or minus the square root of 4/3. Now, remember when we went over this in math time? When you have a huge square root, like the whole fraction is underneath the square root, you reduce the fraction if you can. Can we reduce the fraction? No. Okay, and then we can split it up. So I'm going to pull this over here so I have more room to do this. X equals plus or minus square root of 4/3. Okay, so this can become plus or minus the square root of 4 over the square root of 3. Well, can I take the square root of 4? No. Yeah, what's the square root of 4? 2. So this gives me plus or minus this just 2 over the square root of 3. Are you allowed to leave a square root in the denominator? No. So what do we do? What's it called? Yes, you're right. What's it called? It's what? It's something we blank the denominator. Rationalizing the denominator. Remember that? Rationalizing the denominator. Sounds all fancy. So I got to get the square root out of the denominator. The only thing I can multiply this by so that I don't change the value is 1, which means the numerator and the denominator have to be the same. So I have to multiply by the square root of 3 over the square root of 3. When I do that and multiply straight across, then that's going to give me plus or minus 2 square root of 3 over 3. Can I cancel those 3's out? No, they live in two different worlds. It's going to be a fraction, and that's fine. If I could reduce the whole numbers, I would, but 2/3 is 2/3. Okay, and we write it like this. We do not write it 2/3 times the square root of 3. No way, no how. It's 2 square root of 3 over 3. So all that came from over there is plus or minus 2 square root of 3 over 3. Okay. You like the second zero? Yeah, it's pretty lit, right? It's good. X equals what?
Negative 5.
5, I did. Sorry. I have a teenager at home. I hear that all the time. And he just says it to annoy us now, so it's like always in my brain. We say it back to annoy him, too. Just whatever. Okay, it's lit. Everything's lit. So now I have all this. My x's are plus or minus 2 square root of 3 over 3 and 5. Okay.
I just love your right closing thing.
I know, isn't they beautiful? They get worse as the day goes on. My little squiggly. Yeah, see, it's all that practice. Practice makes perfect. Mine used to be a whole lot better. My left one's always really good. But all right, so let's look at number 5. Bracket off. We're going to list all the possible rational zeros. That's what we did yesterday, right? Then we're going to find all the real zeros. Now, when your leading coefficient is 1, that's exciting, right? Because it makes it a whole lot easier. We don't have to write with this fraction. All I need are the factors of 36. So I'm going to write down that my possible answers, and I got asked today, can I write like POS positive or POS period, so for possible? And the answer is no, because we also have positive and negative things we're going to look at, and you won't know what's what. So it won't kill you to write out the word. So I'm going to start with plus and minus 1. 2 works, right? Does 3 work? Yes. 4? Yes. 5? No. 6? Yes. And then since 6 squared is 36, then I can just go back to the 4 goes with 9, 3 goes with 12, 2 goes with 18, and 1 goes with 36. Okay. All right, so those are my possible answers, right? So now I start figuring out if they work or not. So I'll start with 1. And then we got 1, -2, -18, 36. So this is 1, 1, -1, -1, -19, -19, 17, and that's a big no. So then we try -1. So 1, -2, -18, 36. So 1, -1, -3, 3, -15, 15, 51. Oh, my pen. Still a no, but I can't. All right, 51. So that's still a no. So both 1 and -1, they're out, right? So then I'm going to move on to 2. 1, -2, -18, 36. And 1, 2, 0, 0, -18, -36, 0. So 2 works. Now, remember that when we did this the other day, when I said, hey, this is a factor, and we did it, we couldn't go and do it again because we didn't know what to choose from. We had an infinite amount of numbers to choose from, right? Yesterday, we got this, so we could narrow it down from infinity to this, which even though this is a long list, nowhere near infinity, right? Would you like a way to narrow this down even more? Yes, and that's what's going to be that second piece of paper here in just a minute. So we've already got this far, though. We don't need to narrow it down anymore right now. So since this is 2, my f of x would equal, that first factor would be x what? -2. And then I'm left with this right here, which would be x squared minus 18, because there's no x term because of that 0, right? Everybody with me so far? Can I factor it anymore right now? No, I cannot. Okay. So, oh, I knew that was going to happen. Oh, dang, what the heck. All right. Bring that back down. Been having board issues all day. All right, here we go. So I can find my zeros, though. So here I know that x equals 2. That one is fantastic. Then here I know that x squared would equal 18. So x is equal to plus or minus the square root of 18. And then I need to simplify that.
3 square root of 2.
3 square root of 2, good. Because this is like 2 times 9. You can take the square root of 9. So x is equal to plus or minus 3 square root of 2. And remember, to check yourself to make sure you didn't take the wrong one outside because you're trying to do it too fast, you square what's out here, multiply by what's in here. So 3 squared is 9, times 2 is 18, so we're good. So our zeros then are plus or minus 3 squared of 2 and 2. Okay. Everybody okay with that? Any questions at all? Awesome. So we are not doing any of those examples on the back. We're going to move on to the next part, okay, which is going, let's see, that one was on, make sure I get these page numbers right. This one was 55, so this one's 56. Okay. So we have Descartes' rule of signs. Have y'all heard the phrase, I think, therefore I am? Have you ever heard that? Do you have any idea who said it? Descartes. I know it took a wild guess because we're talking about him, but yes, it is Descartes. So Descartes, and this should be Descartes, like there's an apostrophe here because his last name actually has an S in it. No, it's a French name, so it's Descartes. I know some people say Descartes, but that's like that's not it. It's Descartes. Like the last S isn't even pronounced either. All right, so I'm going to tell you a little bit about Descartes. Even if you don't care, I'm telling you anyway. He was a French philosopher, mathematician, and scientist. Do y'all know what the Cartesian coordinate system is? Nope. Well,
That's what they use to find ships, but they don't.
no, that's cartography, but no, that's all good. That has the same prefixes. The Cartesian coordinate system, you do know exactly what it is. Have you ever graphed anything, like ever? No. Yeah. What you're graphing on is the Cartesian coordinate system. Your x and y plane the x and y axis, the coordinate plane, is their Cartesian coordinate system. Here's why you do care about this. Years ago, so I know we have engineering classes now. We didn't a little while before that, and then before that we had some, they were like different. So the engineering teacher, so this has been a long time ago, but the engineering teacher came to me and said, do y'all teach them the Cartesian coordinate system? And I was like, yeah. And he said, well, how come none of these kids know what it is? And these were like upperclassmen that wanted to do engineering. I was like, that's all Algebra 1 is. Like, yes, they know what it is. Well, come to find out, no, the teachers aren't using those words, not saying this is the Cartesian coordinate. Not that you would use it every day, but at least to say it, because the kids are sitting in his class thinking they have a totally different set of something they've never seen before, like it's a totally different universe, and it's not. They can totally do it, right? And so just want to make sure you do know the Cartesian coordinate system. It's called that because it's named after Descartes. He's the one that developed it. He's the one that first put geometry and algebra together so we could actually figure things out. He was the first one to use X, Y, and Z for variables and like A, B, and C for the constants. He was also the first one to put the exponents as superscripts. So he's responsible for a lot of the math, the way we do math, not the math itself, but the way we do it, which is universal. It doesn't matter what country you're in, doesn't matter what language you speak, math is math. And because he wasn't American, he was French, right? He didn't speak our language, and everything still, transfers over. So, he used the law of refraction. You've talked about the law of refraction in science, right? So he used the law of refraction to figure out that a rainbow's angular radius is 42 degrees. In case you ever wanted to know, might be on Jeopardy one day, you need to know that. So all of but you notice like the rainbows you see, it's not like some of them are squished and flat and some of them are more pointy. They're all the same, right? Has to do with refraction, and the angular radius is 42 degrees. So the law of refraction, he was already developed and he used it. He developed the law of reflection. So he's responsible for a lot of what you do in science, or a lot of the discoveries in science, a lot of the discoveries in math, and then he was also a philosopher. So you could possibly talk about him in your science classes, in your math classes, and even in your social studies classes, maybe your English classes, depending on what you're reading. But there's probably a lot that has to do with him that you don't realize it's all the same guy. Like, he was kind of a big deal. All right, so his rule of signs is going to help us, and it's super easy. It says, in many cases, the following rule, discovered by French philosopher and mathematician René Descartes around 1637, is helpful in eliminating possible zeros from a lengthy list. So those ginormous lists we have, we could possibly eliminate some. Yay for Descartes.
Wait, why didn't you teach us before?
Well, because it wouldn't have helped you that much on some of those. And it helps you more on some than it does on others, because I can't teach you everything at the same time anyway. So to understand this rule, we must first look at the variation in signs in a polynomial function. When a polynomial function is written in standard form, a variation in signs occurs when consecutive coefficients, coefficients have opposite signs. So do you know what consecutive means? Yeah, back to back, one right after another. Monday and Tuesday, Wednesday, those are 3 consecutive days. So your consecutive coefficients are the ones right in a row. So it says, here's the example. How many variations in signs does the function below have? So here's how this works. You have, this 4 is positive, right? So then it's negative. So it changes from positive to negative, so that's 1 right there. Then it changes from negative to positive, so that's another 1 right there. Then it stays positive, then it goes from positive to negative, that's a third one, and it stays negative. So there are 3 variations in signs. Do you see how easy that is to come up with that number?
Wait, say it again?
So this was positive,
Okay.
and then it changed to negative, so that's 1 change.
Okay.
Then the negative changed to positive, that's another 1. But then we stayed positive, that one didn't count. Then it went from positive to negative, that's another 1. Then we stay negative, so there's 3 variations. Okay, that's all we're doing right now. Just 3 I'll tell you which ones go with what. But if you can count like that, you're good. We can figure this out. Okay. So what the rule of signs says, it uses this. It says, given a polynomial function f of x written in standard form, so has to look like this, all multiplied out, real coefficients, no imaginary numbers or anything anywhere. Then the number of positive real zeros is equal to the number of variations in signs of f of x. That's what we just did right here. Or less than that by an even number. So what that means is this. This polynomial right here is going to have 3 real zeros, or less than that by an even number. The even number would be 2. It would have 3 or 1. Even though this is a 5th degree polynomial, no way there's 5 positive ones. 3 at most, or it could be 1. Okay, does that help? I mean, maybe. Not really sure why it works yet, but we'll get there. So then now our number of negative real zeros is equal to the number of variations and signs of f of negative x, which is going to be really easy to figure out, or less than that by an even number. Okay, and I'll re-explain both of those statements as when we actually do one. So one other thing you need to make sure you know is with the rule of signs, it includes repeated zeros. So if I have x minus 1 quantity squared, my 0 is 1, right? But it has a multiplicity of 2. So that positive 1, that would count as 2 of my positive zeros, even though I just write it once. So if I have like, what this statement right here is saying is that if I have x minus 1 squared, my 0 is positive 1, right? But that would count as 2 of my positive zeros because of the multiplicity. Even though you write it down once, it counts as 2 because of the multiplicity. All right, does that help? All right, so here's how this works. It says state the possible number of positive and negative. This is why we can't just abbreviate possible with POS because we're talking positive and negative here. We're going to find the number of positive real zeros here for number 1. So we look at, it starts with a negative number, right? Changes to positive. Stays positive, changes from positive to negative, and from negative to positive. So that is 3 variations in signs, right? So I could have 3 or less than that by an even number, 1. And that's it. So I am guaranteed 1 positive real zero for sure. I could possibly have 3. Okay? We good so far?
What's that sign in the middle?
Oh, that's the word or with my bad handwriting. It's like a capital R that's like stuck. It looks like some weird bow tie. Yeah, I know. Yeah, I don't know. It's or. No, it's okay. It's my bad, really. But so then I need f of negative x. So let's think about this before we start going into this. If I take a negative x or a negative into anything and I substitute it in and my exponent is even, do I get a positive or negative out? My exponent is even, 2, 4, 6, 8. Positive. An even exponent is going to give me spit out a positive no matter what I put in, right? An odd exponent, if I have a negative in there, the odd exponent is going to spit out a negative, right? So when I take my negative x and I substitute it in here, if I have an even exponent, nothing changes. That's still negative 3x to the 4th. When I take my negative x and I have an odd exponent like 3, that's going to change the sign on that term. So basically, you go through and you rewrite it. Anything with an even exponent stays the same. Anything with an odd exponent, you change the sign. And then the constant is whatever it is, because that's what means by constant. It stays the same. Okay, so you don't have to like really think about substituting it in like a whole lot of math. You just have to know what you change and what you leave the same. Are we good at that point? So now I look at this one. And it's negative, stays negative, changes to positive, and then it stays positive. So the number of possible negative real zeros, there's only one variation, is 1.
So 0 stays the same.
What do you mean 0 stays the same?
The 18 stays the same.
Oh, yes, the x to the 0. Yes, I'm sorry. Yes, because I'm not substituting an x in there, so it's a constant, so it stays the same. Yeah, sorry, I didn't know what you meant by 0. So I am guaranteed 1 negative. I'm not going to have any more or less than that, because you can't go less than that by an even number without getting a negative amount, and that doesn't make any sense. So it's possible, this is a 4th degree, it's possible that I have 3 positives and 1 negative, which means all my roots are real numbers. Or I could have 1 and 1, which means I would have 2 imaginary roots. Okay, maybe I have a bounce or something else going on there. Okay, we good? All right, so let's look at number 2. Do number 2, and then I'm going to let you do some. We're going to look for positive first. Is that what it is? Your ears are plugged up? So it's positive, changes to negative, negative goes to positive, positive goes to negative, stays negative, negative goes to positive. So I have 1, 2, 3, 4 variations. And then it says, or less than that by an even number. If I subtract 2, it could possibly be 2, or it could be 0. So I could have 0 positive real solutions. Then I'm going to look for, I have to find f of negative x. So that x to the 5th is going to be negative x to the 5th because it's an odd exponent, minus 2x to the 4th, then minus 3x cubed, minus 6x squared, plus 4x, plus 8. So then my negative starts off negative, stays negative, 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 changes to positive, then stays positive, so I have 1. So let's talk about how we care, how this will help me. If I have to go and I have to do that synthetic division, and I figure out my possibles, or I have like this whole long list of possible zeros, and then I can figure this part out here. Well, it's possible that I don't have any positive zeros at all. And so if I start by checking all my positives, I might be wasting my time. I know for sure I have 1 negative, so if I start by checking my negatives, I can find that, and then maybe I could factor from there. Does that make sense? Or if I'm over here and I find, I do 1 and it doesn't work, and then I do -1 and it does work. I got my negative here, right? So then if I have to go back and check another one, I don't check another single negative one. Like I've just cut my list in half. All the negative ones I've thrown out because I know that none of the rest of them are going to work. So that's kind of how we're going to use that once we get there. All right, so I want you to do number 3. Figure out your positives and negatives for number 3. How many positives do you have? 0. There's none. There's no variations. I do not have any positive real zeros at all. So when I come up with my lengthy list of possibles, guess what? It automatically gets cut in half because I'm wasting my time if I try any of the positive numbers, right? And then negative, how many? 2 or 0, because it's less than that by an even number. It could be 2 or 0. And notice that the numbers, like the biggest numbers, don't even have to add up to give you this. Like we're guaranteed some imaginary solutions in there, which we don't have to worry about right now. Everybody good? So let's just do 4 together, because there was a reason I wanted to do this one too, but I don't remember what it was. So I'm sure there's a good reason. My positive, I have how many changes? 1. Then when I do f of negative x, that's going to give me negative 27x to the 4th. Minus 125x. So the negatives then is 0. So once again, my possibilities that I write out, I've cut the number in half. I don't try a single negative one and I know for sure I have a positive one. And I can go from there. Okay, we good? Any questions at all? So you got to put all these pieces together to kind of simplify the process in the end. All right. Flip it over. We got one example. We're not doing both of those in the back. It is big, and we don't even need that much room. I just spread it out. Don't freak out. We don't need all that room. All right. So it says, create of all possible rational zeros. So we still have to do that. And then we're going to find all the real zeros. We're going to use the rule of signs to help us eliminate possibilities. All right. So I'm going to start with my possibles. Which remember, that's if the leading coefficient is 1, all I really need are the factors of this. So this will be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So then to find to use the rule of signs, I'm going to need f of negative x. So we're going to go ahead and find that. That's going to give me x to the 4th minus 6x cubed plus 7x squared plus 6x minus 8. So then my positive and negative possibilities here. All right, so how many positive real zeros would I have? 1. So these are all positive. I only have one change right there. So I'm guaranteed one positive one, right? What about negative? Say 1, and then 2, 3, or 1, right? 3 or 1. So now we are going to have to go in there and do our synthetic substitution. Now, it is going to help us narrow this down, but since I know I have at least one of each, then I still have to decide where to start from. It may not help you at your starting point, so we'll start with a positive 1, right? So, positive 1, and make sure... Yes, don't forget it. All right, so this is 1, and then 1, 6, 7, negative 6, negative 8, right? So this is going to give me 1, 1, 7, 7, 14, 14, 8, 8, 0. That is beautiful news, right? So, oh, and what I was going to say, I don't know if I said it or not when the announcements came on, but when you go to set this up, because we wrote down f of negative x, make sure you're actually using f of x in there, because that would be easy to mess that up. All right, so now I have f of x is equal to, well, since 1 worked, that means this is x minus 1, right? And then that leaves me with this, which would be x cubed plus 7x squared plus 14x plus 8. Bye. So what we've been doing at this point is saying, okay, let's see if we can factor this. Can I factor this by grouping? Okay, so if I do that, if I'm going to factor out this x squared here, that would leave me with x plus 7, right? Oh, no. Over here, it just wouldn't match, right? Like I could try, but then it's not going to get me what I need, which means that I can't factor at this point, so I have to go test some things again. But look, guess what? I have one positive real solution. I just found it right here. So I am done trying my positives. You with me on that? That's it. All my positives, all I care about, like, they're all gone at this point, right? And so I'm going to try negative 1, which is probably where we would have gone anyway, but. Why is this 6 not negative? Because it came from here. So I said make sure we wrote that down, but we are using f of x. This is what goes right there. So it's 1, 6, 7, negative 6, negative 8. Does that make sense? I probably shouldn't have written it right where I did. But. All right, so we try negative 1. And do I have to try it in the 1, 6, 7, negative 6? No, I can use my reduced one, right? 1, 7, 14, and 8. So this is 1, negative 1, 6, negative 6, 8, negative 8, and 0. That's beautiful too, right? So that means here, this one works. So now I have f of x. And actually, when I said you can use this one, you pretty much have to, because if you don't, then you're not reducing that.
Freshmen only with a hot pink ticket may be released for the pep rally.
All right. So it's still not factored all the way, but can I factor this? Yes, at least we think we can. We can try. If not, we'll have to go back to there, but this is going to give me x minus 1 times x plus 1, and then x and x. What are my numbers that go in here? 4 and 2. So now I have it all factored. This is my fully factored form. And then my zeros, I'm going to get plus or minus 1, negative 2, negative 4. I probably should have written that in a different order, but it's okay. We okay with that? Now let's look at what this is probably not the best example in the world for me to choose to show you how Descartes' rule of signs can really help you, because you probably would have gone with 1 and negative 1 anyway, right? But if you did have to continue, do you understand why you would not try any more positive numbers? Okay, that's what's going to help you. And if positive said 0 to begin with, great, I don't try any of them. I just start with my negatives, and it's going to help you with your choices there, okay? Any questions at all? We good? Awesome. You got to make sure that you're understanding synthetic division, because we're still not done using it. We're going to use it a lot. All right, so we're done. You can go ahead and glue those both in right now so that you're not worrying about it later. I'm going to give you your assignment. And remember, on your assignment, you're only doing 1 through 9.